are we even doing here? I don't really know. So we'll have what is it we're going to do? Asynchronous operations sequentially. Hello again, thanks for joining me. Today we're going to have a very quick look at how we would go about running asynchronous operations sequentially in Typescript. So what does that mean? That's a lot of words. Basically, say we had a list of network requests or some sort of asynchronous work, something which would take some time to complete. So we had a list of these operations. We had a couple of choices about how we could tackle that. We could either handle it that all of them go off and happen in parallel, and then we get all the results back, and we could use a promise.all to wait until all the results are in and then move forward. But there's a use case where you would need to handle one operation and then another and then another. One example of this, which I've come across a lot, is when you have rate limits on APIs. So say you're only allowed 10 concurrent requests against a third-party API. Well, you're kind of limited to only requesting 10 at once. So one alternative to that could be just run through your list of network requests sequentially, one after the other, wait for the last one to come in, and then fire off the next one. So that's what we're going to have a look at today, because there's a little bit of a it's a little bit confusing how it might work, and it can trip you up if you forget to do one very important thing, which we'll get to. So before we start then, let's just say we have let's just construct our list of work. Can't really spell today, that's okay. Okay, so this is just an array, and this is going to be an array of just simple promises. So you can just actually wrap anything in a promise by just calling promise.resolve or promise.reject if you want it to be a rejecting promise. And this will resolve immediately, but it's still a promise. So we can change this slightly in a minute, and we can even add some sort of like a timer so that the promise will resolve after, say, 100 milliseconds or something like that. So we're just going to keep this really, really simple. I'm just going to resolve some numbers here. So we're going to resolve 1, and we'll just do, let's say about 5. Let's just do 2, 3, 4, and 5. There we go. So it's just going to resolve 1, 2, 3, 4, 5. Nice and simple. Okay. So if we wanted to do these in parallel, we could go about it by doing, I'm just going to actually wrap this in an iffy, and just so we can start using some asynchronous code here. Oh, if I could remember the syntax. There we go. So an iffy is an immediately invoking function expression, and it's quite handy for being able to access async work, being able to access and use async and await immediately inside of a file. This is a really common pattern before async was around, back in the ancient Stone Age times. Soon enough, there will be top level await that you can just use just straight away to start awaiting things on the top level of the file, which is just very nice to use, but takes a bit of setup. So for our use case, we're just going to not bother with that. We're getting actually a TypeScript error, has no callable, missing a semicolon. How about a semicolon for you there, sir? Okay, cool. So it was trying to call it, I think, because, yeah, it was getting rid of the white space. Cool, so we're inside our asynchronous function, so we can start just calling stuff. If we wanted to get a list of the values which were resolved from these promises, we would be able to do a values equals, we'd have to await a promise.all list of work. Now, promise.all, it takes a list of promises and then returns you the values. It waits until all of the promises have resolved and then gives you back all of the values. So you can see here that if I just hover over and get the type hint, this is a promise of number array. That's what this type annotation here says. It's a promise which wraps a number, and it's an array of those. So it's a big list of different promises. If I then hover over values, we can see it's literally just an array of numbers. So you would get this values would be 1, 2, 3, 4, 5. Unwrapped, ready to go. So maybe we could even just make this a little bit more of a complicated example, maybe. So say instead of this, if I just get rid of this, instead we could say maybe we've got a list of IDs. So we already have these values of IDs. And say we wanted to... Say we needed to do a network request using this ID and then go and get the result. Say it was like, this is the ID of a user or something, and then you would make a query to get the details of that user by their ID. So we could do IDs.map. So this is going to be for each item in this array, we're going to map over. So this gives us a callback with an ID. So there you go, it's each item. So in the first iteration, it'll be 1, in the second, it'll be 2, etc., etc. We can do anything we want in here, but let's say we had a fetch request that wanted to go to api.com user, and then we wanted to like inject that ID to get the resource, say. Okay, this, let's just return it. We could just do this on one line, but we'll just do it a couple of lines to make it super clear. So this is actually going to be a promise it returns, but we could make this even clearer by turning this into an asynchronous function. So we can say an async ID, and maybe even say result equals await, and then maybe even return the result. Okay, so what's happening here? So we're running an asynchronous function on every iteration of this array. So for each item, we're running an async function. We're going to go off and do a fetch request, await for the result, and then return the result. This values will then be a list of results which come back from fetch, as you can see here, response array. Nice. Okay, so as I said, this is actually happening in parallel though. So it's going to send all 5 of these requests off at once, ping, 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 and then get all of them back. Once all of them do come back, then it gives us our values and then continues on to whatever it is that we want to do down here. Use values. There we go. Use them to do something else. Cool. Okay. That's nice, but what about if we wanted to? What if we wanted to run these sequentially rather than in parallel? So say we're actually querying api.com, and api.com it will actually only let you do one concurrent request at a time. So instead of using map, we're going to do something slightly different. So I'm just going to get rid of this. So we are going to say we'll say const values again, and it is going to have to await the response of this. We're going to get the IDs. And instead of doing a map, we're going to do a reduce. So reduce is freaking awesome. It's the best of all of the array functions. Also the most confusing, but it's the most powerful. So reduce takes a list of things and it reduces it down to something else. Can be anything that you want. Literally anything. Could be a number, could be an object, could be another list. It could be a longer list, but it's reducing it from one side to the other. In other languages, they call this fold. So it's like folding one list into another entity, whatever you want it to be. Very nice. Okay, so reduce takes, in this instance, an asynchronous function, just like we saw with map. That's the first argument. I will come back to what the arguments of that are, but the second argument, as you can see here, is the initial value. That initial value is really important. What we call this is what the type of this initial value is very important, because then TypeScript is going to use that to decide what happens on each iteration. You can't change what value is passed through to the next iteration. So how reduce works is it will go over each item in the array, it will run this function, but you can actually return something from this function, and that gets returned ready for the next callback. So you can pass state forward into the next iteration. It's really cool. So that might be a bit clearer if I actually fill in these arguments. So in terms of naming of these arguments, I tend to go for like I might name it in full this time, but accumulator, yeah, makes sense. So it's the accumulated value, what's happening, it gets added to on each iteration. And then the second argument is going to be item. If we hovered over these, we can actually see what they are. So the item is a number. So that's going to be, first it's going to be 1, then it's going to be 2, then it's going to be 3, then it's going to be 4, then it's going to be 5. The accumulator is going to be whatever gets returned from the previous iteration. And on the very first pass, when item is 1, it's going to be whatever we put in this initial value. So initial value is, we don't actually know at this point, but whatever this value is going to be here. So you can see it's an any because we haven't actually named it yet. So we could say we wanted to add all of these up, maybe adding them is an asynchronous operation. Can't see why it would be, but I mean, maybe we can pretend it is. Maybe we want to add up all of the, okay, we want to add up we want to get the total age of every, so these refer to user IDs. That's what we'll say first of all. So let's just even rename it just so it makes it even clearer. User IDs. We're going to go over each one and we want to get the total age of users. That's what we're looking for. Okay, so you might start with, well, there's no users, so at the beginning the total age is 0, and then as we go over each one, let's say we have a network request in here. Let's say details equals, this is pseudocode, by the way. This is not going to call an API. I'm not going to bother setting up anything to actually do any of this, but let's just say we'll go back to our api.com/user/ I'm actually going to rename item now because we actually know that this is an ID. This is a list of IDs. ID is a much more idiomatic name for this variable, and naming things correctly is the hardest part, but also it's the most useful part. So that's what we're going to stick to. So we're going to pretend that if we go details, I think fetch will give us. Oh yeah, you have to do the. Okay, we'll pretend it's real. Let's just say, oh wait. So interesting fact, fetch actually only goes off and gets the headers of a request. And then you have to call res.json. You have to call the JSON operation. That will actually start decoding and parsing the JSON response from an API. And it's the same with, is it XML? Is the other method? Or text? Text, yeah, it's the same with text. So it just goes off, gets the headers of the request, of the HTTP request, and then the second part, this is why you've got to wait twice in a fetch request if you're using the browser's native fetch API. The second part is when it actually passes it and then turns it into something that's usable within your code. Okay, cool. I feel like, does it give you data or is that Axios? I cannot for the life of me remember. Okay, we'll just pretend that this is details, and I might even just cast it to, let's just say we've got age number. There we go. So we can say that the age, we can just destruct it immediately. Let's just grab the age from details. There we go. Nice. Or you know what? Let's just be even cooler about this, and let's do it on one line because everyone loves immediately destructing things. How could you not? So clean, so nice. Okay, so we've got the age of this particular user by their ID. So we need to add these up. So we've got it on this iteration, but how are we going to pass it forward? So we actually need to use the accumulator. That's the accumulated ages so far. So at the beginning, it'll be nothing. Second pass, it'll be whatever the first person's age is. Third pass, add them together, keep adding them. And at the very end, that will be the total age if we just keep adding at each iteration. So let's say accumulator plus age. Let's even just call it new total equals accumulator dot age, and we will then return new total. Very nice. Okay, this is not going to work, and this scribbly is telling us why. So let's just give it a little hover. Is this big scary thing? Promise number is not assignable to type number. What does that mean? What does it mean? What does that mean? Okay, I'll tell you what it means. So, okay, it's basically, this is of type number, and then the return from the first iteration is actually of type promise wrapping a number, because we're doing some asynchronous work. That's what an async function returns. It's the return type, but wrapped it, a promise wrapping it. So it's now, so what's happening, this would actually be fine in JavaScript, I'm pretty sure, maybe, I don't know, might break, I don't know. Either way, it's not good in TypeScript because you need to be like rigid about your types. It's got to stick to the plan. You can't just go casting things left, right, and center. And that's just it's a big area of bugs otherwise. Okay, so instead of it being just nothing, 0, we need to actually have this as a promise wrapping 0. Promise.resolve 0. Okay, so this is gonna beat our scribbly up here. So it's the same type. So it's a promise of number. That's what promise.resolve is here. It's telling you, look, there we go. That's the type of promise.resolve 0 is a promise of number. The return type from this asynchronous function is also a promise of number, but we have a final scribbly here. You can't actually add a promise of number to a regular number. So did I forget to use await? Yes, I did. Yes, I did forget to use await. So if we want to do this sequentially, we're going to need to await the previous one and then run the next iteration. So on the very first line, I'm going to say previous total equals await the accumulator. And then we can change this to the previous total plus the age. Okay, so what's happening here? We're waiting for the previous promise to resolve. That's the total. On the first iteration, it's 0. We go through, we get the details, we get the age, we add them together, and then we return it. This is some async work happening, so we've got to then, on the next iteration, wait for that async work to be done, because we don't know what the current age is on the iteration until we've got that result in. Next result comes round, we find out what the age is, and then we start all over again. We keep going until we get to the very end. When this array is finished, when we get to the user ID 5, boom, the await returns, no longer awaiting, and we get that total age of users, and that gives us the total age. Bada bing, bada boom. I hope that is clear. But those are your two, basically. You can either do them, you can use a map and then promise dot all on that map, and then you'll get the results which have fired off in parallel, or you can use reduce and then just like ping one after the other. And it really is as simple as that. Thank you very much for watching. I'll see you in the next one.